This is the third video in a series of videos I've created to help my students become more comfortable in the field of organic chemistry. Now this is going to continue with the nomenclature of hydrocarbons, picking up where video 2 ended. And just as a quick reminder, I placed this example of IUPAC rules that we discussed from video 1 on here. Remember that you always want to find your longest chain of carbons without backtracking or lifting your pen. You want to look and see, do I have double, single, or triple bonds? If I have single bonds, I have an A-N-E ending. If I have double bonds, I will have an E-N-E ending. And if I have triple bonds, I will have a Y-N-E ending. So as I look at this right here, I have 5 carbons, so I'll have the prefix pent. Only single bonds, A and E. So I have a pentane. I next want to look at this little chain coming off. This little chain is composed of 1 carbon, so it's a methyl. YL indicates little chain. It comes off of carbon 2, so I have a 2-methyl pentane. If I have 2 that are exactly the same, and these are 2 methyl groups, I would want to indicate with the prefix di. Longest chain here is 4, so I have a butane. I have both of these coming off of carbon 2. I do need to indicate the 2 twice, so this is a 2,2-dimethyl butane. Now I indicate the 2 twice because this is coming off of 2, this is coming off of carbon 2. Now moving on to cycloalkanes. Cycloalkanes are when we have single bonds, but you'll notice they are enclosed. And it doesn't mean that they are a circle, it just means that they're interconnecting. And the way we name these follows the rules we looked at on video 2. We count the number of carbons in that longest chain. In this case it is 3, so I use the prefix prop. I have single bonds only, so I have a propane, and the only difference is because that this is circular, I would add the prefix cyclo. So this is a cyclopropane. On this one, I have a chain of 4 carbons that are single bonded, so they are circular. This would be a cyclobutane. Both the cyclopropane can be drawn in this fashion or this fashion. Cyclobutane can be drawn in this fashion or this fashion. Once we get to cyclopentane, we do tend to draw it out, and each of these points represents where a carbon would be. So this point right here represents our carbon. Here this one represents a carbon, carbon, and carbon. Now we know that all carbons have a maximum of 4 covalent bonds, so this carbon's bonded 1, 2, it would have 2 hydrogens coming off of it to complete those 4 bonds. We do not need to include that because it is understood that an organic chemist would know this. Here's a cyclohexane. Now we can also name chemicals where we have something coming off of our cyclo compound. So here we have a cyclohexane, and then we notice that we have 1, 2, 3 carbon chain coming off, and this is a little chain, so this is a propyl. So now we have a propyl cyclohexane, and then we have this little chain coming off of carbon 1. So we have a 1-methyl propyl cyclohexane. Let's look at this one right here. Now on these, any one of these can be carbon 1, so this could be carbon 1, this could be carbon 1. What we want is we want our little chains coming off of the smallest carbon possible. So this would be a 1, 2, 3, 4. If I went this way, this would be 1, 2, 3. We would have it on a 4 and on a 6. So we're going to count in this direction. Notice that they're all the same. They're all methyl groups. So we would have a 1, 2, 4, tri, because they're the same, methyl cyclohexane. Here we can count and see that we have a cyclobutane, and we have this coming off, so we would have a 1-methyl cyclobutane, and in that case we could leave the 1 off. Here we have a cyclopentane. We have a 1, 2, 3. Now, could this be carbon 1 or could this be carbon 1? And the way we determine on these is by alphabetical order. So this is going to be carbon 1 because ethyl is first in the alphabet versus methyl. So we have a 1 ethyl, 2 propyl, 3 methyl, cyclopentane. 1 ethyl, 2 propyl, 3 methyl, cyclopentane. Additionally, we can have substitutes that are different than just a multiple bond or just a little carbon chain. And the most common substitutes that you're going to run across are going to be the halogens. Remember that the halogens are the elements from group 17 on the periodic table, and they consist of fluorine, chlorine, bromine, and iodine. So fluorine would be fluoro, chlorine would be chloro, bromine would be bromo, and iodine would be iodo. So that in this example right here, we would have a 1,1-dichloro 3-propyl cyclohexane. On this one right here, and again we're going to go alphabetical, so this is carbon 1. This is going to be a 1-bromo, 2-chloro, 3-methyl cyclobutane. Looking at this one here, we would have a 1-chloro, 3-methyl cyclopentane. Here we would have a 1-bromo, 1-chloro cyclobutane. Moving on to alkenes and alkene nomenclature, simple alkenes are named like alkanes, except that alkene will have a double bond where the alkane only had single bonds. And so to begin with, we will find our longest carbon chain that contains the double bond. But instead of having the ending ANE, we will replace that with the ending ENE. And when the chain is longer than 3 carbons, we will number where the multiple bond is. And we want the double bond to be on the lowest carbon number possible. So if we are looking at a little chain coming off and the double bond, we count in the direction where the double bond is on the lowest carbon number possible. If we have a ring-shaped structure, we will also include the prefix cyclo, just like we did on our previous slides. We can also have alkenes where more than one double bond is present. If we have 2 double bonds, it is called a diene, di2, ene, double bonds. If we had 3 double bonds, it would be a triene. If we had 4 double bonds, it would be a tetraene. Now as we look at this, and we're going to use this as our example, and we count our longest chain is 9, so we have a prefix of known. We have multiple bonds, we have double bonds, so we have an ENE. Now you'll notice that we have 1, 2 double bonds, so we have a nonadiene. We do want to indicate where these double bonds are located. So the double bond is located between carbon 1 and 2, and then we count over between 4 and 5. So we would use the first carbon that it's between on each of these double bonds, so we would have a 1,4-nonadiene. Sometimes instead of calling it 1,4-nonadiene, we will call it nona and then 1,4-diene. And the 1 and the 4 is telling us where the double bonds are located. Either one of these is completely correct, and you should choose the one that you are most comfortable using. So in this example, when we look at this, we know that we have 6 carbons, so we know we have the prefix hex. We have 1 double bond, so we know we have the ending ENE. we have to determine, is this carbon 1 or this carbon 1? If this is carbon 1, then we have a multiple bond coming off of carbon 4 and 5. If this is carbon 1, we have the multiple bond coming between 2 and 3. So we want this to be carbon 1. And so we would have our double bond between carbon 2 and 3. We would have a 2-hexene. So on this page here, we just have the IUPAC and the new IUPAC naming system for alkenes. So on this one here, 4 carbons, double bond. Double bond is between the 1 and 2, so we could call this a 1-butene, or we could call this but-1-ene. Again, we could call this one right here with 5 carbons with 1 double bond coming between carbon 1 and 2, a 1-pentene, or a pent-1-ene. And either of these is correct. It really comes down to which system that your professor uses in class. So pick up on which form your professor uses and tend to go with that direction. With our cycloalkenes, we're going to name these the same way we did with our cycloalkanes. Now on this one right here, what we're going to notice is that we have 2 double bonds, and so we know that we have a diene. We know that we have a 6-carbon structure, so we have a hexadiene, and we know that it comes between carbon 1 and 2 and 4 and 5. So we would have a 1,4-cyclohexadiene. Now on this one right here, we know that we have a 6-carbon compound. It has a multiple bond here, so we have a cyclohexene, and we have this little chain coming off of carbon 1, so we have a 1-methyl-cyclohexene. Here we have a cyclopentene, and it's between carbon 1 and 2, so we have a 1-cyclopentene, and you'll notice that we have this coming off of carbon 1 and carbon 5. Again, we want this to be carbon 1 and 2 because that keeps our multiple bond on the lowest carbons possible. So here we have a 1,5-dimethyl 1-cyclopentene. Now on these alkenes, I want you to notice that the presence of the carbon-carbon double bond can create 2 possible structures. We can have the structures where both of our little chains are on the same side, or we can have it where the structures are across from one another. So in this situation, the cis isomer is going to represent where the 2 similar groups are on the same side of the double bond, where on the trans, the isomers, the similar groups are going to be on opposite sides. So you can separate these from one another based on their chemical properties, and so we need to identify these based on where those similar little chains are. So this right here would be a cis, and this is a cis-2-butene because we go 1, 2, 3, 4, and so our double bond is between carbon 2 and 3, and that's where we get the 2-butene, and the cis is because both of these chains are on the same side. Now on this one we go 1, 2, 3, 4, so we still have a 2-butene, still between carbon 2 and 3, but we say it's trans because these are on opposite sides of the multiple bond.